Okay, so the second exam score was posted in a Blackboard, and the max score for this exam is 100, and the mean is just a little bit over 50, and median is exactly 50. 그러니까 뭐 최고점은 100점, 그 다음엔 평균과 중간값은 평균과 중간값은 모두 50점. 오케이. So this is the histogram where X is a total score of the first exam and then the second exam. And okay, so we have a little bit heavy tails on the left of this exam. Then we have maybe 3 peaks, and then some top scoring students, around 95. Okay, let's see. And this is the score per problem. So when normalizing the max score of each problem in the first and the second exam, so one means one corresponds to the maximum score of each problem. And previously in the previous exam, the second one was relatively high. So most of the students did well on the second problem. But in the second exam, problem 4 was the most tricky, turned out to be the most tricky one. And you guys have the exam sheet as well, so it's about some proof. Okay, so although it was supposed to be quite simple, but not many students didn't catch the point about how to prove this problem. So that's why it became a little bit lower than the other. And this is something called a scatter plot. So each point is one student. Okay, so over there somewhere, you are corresponding to 1 point, and the x-axis and y-axis is your own score for exam 1 and 2. So roughly, this lower part, like a lower triangular part, are corresponding to those students who did not very well on who did well on the first exam, but not on the second exam. And the upper part is the opposite case. Okay, so there are some students who did not very well, scoring maybe about 67, but he or she did very well, scoring maybe 93 or 4. And this orange line is the linear regression line. So you studied the linear regression at the end of chapter 6 after QR decomposition. And then we studied this chapter. And so here what we did was to find the best fit, as this is a single line, like a y equals ax plus b, and we try to fit that line where x is exam 1 score and y is exam 2 score. Okay, so we are basically trying to minimize the difference between the difference between the function value over here and the actual value. So around this part, we are underestimating the exam 2 score. So this kind of model, although it's so simple, it can be viewed as like the model that predicts the second exam score based on his or her previous exam score. Okay, so some students were fitted up almost perfectly along this line, and this line, for some students overestimated. So we based on his or her scores of 80 in the first exam, we expected him or her to have maybe 78 or so, but the student did not as well as the prediction, scoring maybe 58. And overall, this line is having this coefficient. So the slope is slightly less than 1. Okay, so 0.87, and the y-intercept is 6.8. Okay, so that's why we have this line, and you guys know how to compute this line, right? So we have a normal equation, A transpose A times X equals A transpose B. So here, what is B? What is B? What is B? Okay, then let me just postpone explaining it just a bit. Then let me show you the final one. Okay. So this is a bar graph or histogram, and it's actually three-dimensional histogram. And the height of this bar and also the color corresponds to the frequency or the number of students corresponding to this bin. Those students who had a score around 43 and 58, we have approximately one student. And so here in this figure, it has some problem of if we have the two student or two or more students that had the exact same pair of exam 1 and 2 scores, and then they will coincide exactly with each other. So in that case, we cannot see how frequently or how many students are placed in a particular position, right? So this can be viewed as another version of this, where the color encodes or color represents the number of students or frequency, for each grade. Okay, so any questions? Okay.